Welcome to Liana's series of episodes. Today we have the pleasure to host Nathalie. Nathalie has a background in aerospace engineering and is particularly passionate about space exploration. She has experience in consulting in the public and sustainability sector, and she currently works as a mission manager for scientific payloads on an orbital flight vehicle. As an advocate of the positive impact of space exploration, she will explain to us why space is much more than millionaires and governments spending lots of money, as the application possibilities of space technologies are much broader than many people might think. Nathalie, welcome.
Thank you. I'm very happy to be here.
Okay, Nathalie, before jumping into the questions, I would like to ask you, what is a mission manager for scientific payloads of an orbital flight vehicle? Because this sounds amazing, but I'm not sure what it means.
So basically what I do is that I'm a technical focal point for the customers of my company. And what my company does is that they build a capsule that is going to fly to space. And then for the first mission, we're going to have about 30 minutes of microgravity, and then the payload, which is basically scientific experiments, can use our capsule as a platform to use this microgravity in order to do research.
Okay.
And basically, I make sure that they can be compliant with all the mechanical interfaces, electronic interfaces that we have to make sure that everything runs well and smoothly.
Okay, that sounds like a very interesting job. Okay, so now we can jump. First, I would like to ask you, for a general audience, can you explain us a bit what is space observation versus Earth observation? Because I have known that they are different things.
Yes. So basically, it's the direction of where you're looking. For space observation, you look out into the universe. You want to understand, okay, what is going on with the stars, with galaxies, and all this type of thing. So you're looking away from the Earth. For Earth observation, you're basically sending satellites into orbit or geostationary orbit of Earth, depending on what you want. And then you use this in order to look at Earth.
Okay.
And Earth better. So there's a lot of application possibles for these Earth observational data. So you have, for one, that environmental monitoring, but you can also do some climate change studies. You can do weather forecasting with it, resource management. Urban planning actually also can be supported a lot by Earth observation. And also if you have disasters, for disaster response, humanitarian aid, all of this can be really a lot supported by Earth observation.
Okay, and so as I understand, we take a satellite, we send it to outer space, and we use it to observe the Earth. Exactly. How is this related to global navigation satellite systems, or GPS, as many people may know it? How are they related?
So basically, you have all of this data of the Earth that you have pictures or from other sensors, but then you still have to know, okay, where am I and where is this that I have looked at? So you have all this navigation satellite systems that tell you exactly where you are, and they also tell you at what time it was.
Okay.
So you take all of this together to know exactly what you see and where you see it.
Okay. So they are like complementary technologies. One thing is Earth observation, which provides you data of what is happening on Earth. And another thing is the global positioning systems, which help you understand where was that data gathered and when, right? Exactly. Okay, and what is the role of Copernicus within all of this?
So Copernicus is a huge initiative, mainly by European governments, which gathers Earth observational data.
Okay.
They also gather some in situ data, but mainly what they want to do is have a huge repository of Earth observational data. And most of this data they put on the internet for free. So basically everybody can access it and use it in order to find their own applications and to use it for the better.
Okay.
You have data of, I think, 16 terabytes per day. So it's really a lot of data that they produce per day.
Okay.
And you can access it for free in order to solve issues basically with this data.
Okay. Okay, thank you. Now, maybe it would be interesting to get a little deep on what's the life cycle of a satellite, because I think I have a clear picture of what can be done once the satellite is in outer space, but how is it deployed? How long is it operative? How is it dismantled? I mean, can you tell us a bit about the life cycle of a satellite?
Yes, of course. So, I mean, of course, at first the satellite gets manufactured, and then it gets launched with a rocket.
Okay.
So you have different types of rockets. You have smaller rockets called micro launchers for smaller satellites, basically, and then you have big rockets like Falcon Heavy that can bring a huge amount of satellites, or like very, very big satellites, into orbit. So, of course, the rocket launch is not the most sustainable thing ever.
Okay.
Still has to be a lot done in order to make these more sustainable. But once the satellite is in orbit, it really depends. A lot of times satellites stay in orbit longer or stay operational longer than they were expected to be. But actually, it really depends to say. It's hard to say the exact lifetime of a satellite because it depends also on the application. So it can be operational for decades, but I think most of them are around like 15 years. But also, to be honest, in recent times, it's become accustomed to actually design them to have less lifetime. 4 to 6 years, so that you can replace them more often with newer technology. Which is actually not the best thing in terms of sustainability. So you can see the satellites can do a lot for the sustainable development goals, but there also has to be a lot done in order to make the whole process of going to space and using space sustainably. A lot still has to be done there.
I see. It's a very honest thought. Thank you very much. So, okay, I have a general picture now. The satellite is placed in a rocket, which can be of different types. It is launched. It remains operative for maybe 4, 6 years, 15 years, or some of them decades. And then how are they dismantled? Can they be returned back to Earth? Are they reused in some way, or not right now?
They cannot be returned to Earth usually. What is done, depending on the orbit that they're in, they're either you make sure that you have enough propellant left to propel them out into an orbit that's called graveyard orbit. So basically, you just deposit them there and just let them be there because you can't do anything with them anymore, and hope that out there in the graveyard orbit, they're not going to bother anybody.
The graveyard orbit.
Yes.
But
then, depending if it's like a lower orbit, so like a low Earth orbit, so you have low Earth orbit, and then you have higher orbits, basically, for example, the geostationary orbit. So the geostationary orbit usually go to a graveyard orbit, but for low Earth orbit, you basically let the satellite burn up in the atmosphere. So you make sure that it controllably, like you control it to enter the atmosphere how you want it, and then it burns up so that nothing is left of it.
I understand now. Thank you very much. Now that we have a general overview of how the system works, we're going to get deep on 4 case studies that we have selected. And we are going to start by farming by satellite. As far as I know, the farming industry is the one with the biggest potential of being beneficiated by satellite data. Is that right?
Yes, they can benefit a lot from satellite data. So basically, you can use the observational data that you have and get different insights from it. So, for example, you can look at the crops, how they're growing, and you can see, okay, where do I need to water more? You can do like pesticides. You can put very, very specific at certain points where it's needed, and same with the fertilizer. And this way you can save a lot on actual fertilizer and pesticide, I think up to 20% that you can save, while at the same time increasing the yield of these crops by, I think, around 10% or something like that. So you can really make sure that you have more crops that you can harvest while using less resources.
Okay, so we can understand that in this regard, it really helps like farming activities in this regard of pesticide crops. And can you explain a bit more how this will impact like farming activities and the goals like related to the SDGs application?
So for the sustainability development goals, basically there's multiple goals that this benefits. So for one, no poverty, but also zero hunger. Because if you have more crops, you can of course help people have more to eat. And for also really small farms and rural regions where they don't have a lot of money, if they have more crops that they can produce, it helps them get out of poverty.
Okay. And which data is provided? How can it be useful for the end users?
Basically, through the internet, there is a platform that people can access, and then they can make use of this data. So they have there's different types of data. There's just basically images, but then there's also like infrared images and just different types of showing what you have. And from these images, you can see, okay, where is a lot of water in the ground. You can extract, okay, how green is it there? And from this, you can see how well does the crop grow. So you can run different algorithms on this data to understand what is happening there, and then to find out what needs to be done in order to improve these crops there.
Okay. And who can use those data? Which kind of profile is using the database?
Basically, everybody can access it, but of course you need internet to access it, and you need the knowledge to run these algorithms or to build these algorithms yourself. So there's a lot done in order to try to provide this data, also sometimes already like the insights from the data to farmers that use it, also to developing countries. Because people try to make sure that everybody can use it and that everybody can access it and benefit from it.
Okay.
Of course, especially with this application, you have like in the rural regions where people don't have a lot of internet, it's hard to tell them, okay, here you can go exactly there and put more fertilizer. It's not really that, it's harder. But for regions where the internet and where positioning systems are more in use, it's a very, very good tool.
Okay. And is this application scalable and inclusive?
Yes, I mean it's really scalable. You can use it. Technically, you can use it for the smallest farms, but also for the biggest farms. And as I said, with the inclusivity, there's a lot done to try to include as many people as possible. But for the most rural regions, it is of course harder to include them.
Okay. Because you need internet connection, you need GPS to be active in your area, and you need also basic knowledge on how to develop algorithms that use this huge amount of information. So
and you can also use the information that is gathered by these algorithms, but then you still need to have some device that gives you your exact position in order to use it.
Okay.
So, I mean, the positioning systems are available everywhere, but you have to have the devices in order to make use of it.
Okay.
So having this equipment is basically what hinders many people to use it properly.
Do we still have area on Earth who doesn't have access to like internet and the GPS coverage?
GPS, I mean, it's a global positioning system. Basically, it should be covered everywhere. For the internet, there is a lot going on at the moment to try to have internet everywhere. There are some regions that until a short time ago did not have proper internet access. but especially, for example, with the Starlink constellations. I don't know if you heard of it. It's just
explain it a bit, Nathalie, because maybe someone in our audience is not familiar with it. Explain it a bit, please.
It's a massive, really, really massive satellite constellation that aims to provide internet all around the world. But here we're back to millionaires because it's from SpaceX and Elon Musk. But it is a good initiative, apart from the fact that it's just a lot of satellites.
Okay, thank you very much. Then we can jump into the second case study, which is satellite technology for water availability information. We already touched this a bit, but can you explain how satellites can help us with water detection and management?
So basically, as I said, you can extract different information from the data. And one information that you can extract is the soil moisture, for example.
Okay.
So, how moist is the soil? And you can also see the development over a time period. And from this, you can derive forecasts. Also, then together with weather forecasting, you can basically derive a general sense of knowledge of how the water availability might develop. And then based on this, you can take actions.
Okay.
And on the other hand, you can also see, okay, how is the water used? And then from this, you can know, okay, I mean, of course, most usage is done by agriculture in terms of water. But you can also see, okay, where maybe can you try to limit this use a bit?
Okay.
Use a bit less in order to have more water available in the end.
Okay. And can I ask, because many of us have already applications in our mobile phones that will tell us weather forecast, for instance. Could it be that with Earth observation and GPS systems, could it be that such forecasts have an enhanced precision in the forecasting? Because one of the main drawbacks of water predictions is the lack of precision in the forecast of water availability.
Exactly.
So
and
I assume.
Exactly.
Yeah,
and this will help be more precise because you have this huge amount of data of past years, past water cycles. And then from this, you can build algorithms that derive what the patterns are. And then you can apply this to your current cycle and what you currently see.
Okay.
So basically, you can use artificial intelligence and then have a lot better predictions of what is going to happen. And this way, hopefully, be able to have a more stable water supply and to be able to react a long time before it gets too severe.
Okay. So, for instance, if we have a SME, like a small or medium company working in Ghana, we can say, right, which is a country upon the Guinean Gulf, and there's a small or medium company that produces, well, it's devoted to agricultural activities and needs a precise forecast of water availability or of the state of the soil in a certain season. Well, Earth observation can provide him with such information, right?
And also, like, it's used by companies, but also a lot by governmental agencies.
Okay.
To make sure that there is enough water there for the general public. So not for big companies, for agricultural farms, but also for your own everyday use.
Okay. And can I ask, how back can you go with these forecasts? I mean, we can make a forecast 6 months in advance, or that kind of forecast would have a big margin of error.
Exactly. The longer the longer duration that you forecast, the less precise it is.
There you go.
But basically, for the short-term forecasts, they're quite precise. And then for the long-term forecasts, they're still more precise than they were beforehand. But they're still not super precise.
There you go. Okay. Thank you very much. Well, I assume that the Sustainable Development Goals that do beneficiate from these applications are the same that the ones that beneficiate from the previous case of study, right?
Uh, in some ways, definitely. I mean, also definitely. But for example, there's also one Sustainable Development Goal that focuses on clean water and sanitation.
Okay.
And this is directly benefited by this.
Okay. Okay, I can see.
I also wanted to ask, like, more or less, sometimes we have like artificial lands, like in the Middle East, and how this technology include that, like how they're using it to improve the areas, or how is it involved? Do you know?
Honestly, I'm not 100% sure, but in general, everybody can access this. And I'm sure that there's many applications where it could be used in order to enhance the life there and to enhance the availability.
Okay. And it's free of charge,
Yes.
but who is financing it actually?
Government.
The
It's-
European Union.
Yeah.
Melissa. I think we lost her.
Yeah.
Melissa?
Yes.
Okay.
Yeah. It's basically financed by multiple governments together. So it's really a big European initiative that tries to include everybody.
Okay.
Okay, perfect.
Thank you very much. We can go for it, Melissa. Go for the next case.
Okay,
case
so
study.
now we can jump in the next case with Copernicus for solar forecasting efficiency after the water management. So can you explain us how Copernicus, you already talked about it, how it helped improve solar forecasting efficiency?
Yes. So basically, the problem behind this is that for solar plants, you need to know how much energy are they going to produce, because the people that take care of the energy grid want to make sure that they have the right amount of energy at all points in time, because nobody wants to have an energy shortage and not get the electricity that they need at that moment. But in order to ensure that, and in order to incorporate solar power properly, they need to know how much solar power are they going to get and how much power are they going to need from other sources.
Hmm.
So basically what you can do is that you use the data that you have on weather forecasting in order to know, okay, how is the cloud coverage going to be? How much solar radiance are we going to have? And from this, you can then derive how much time are we going to actually have where the solar plants are going to be active and where they're going to get sun, and also roughly how much sun are they going to get. And then from this, you can derive how much energy are you going to be able to produce. And then you can use this in order to know, again, okay, how much energy do I need from other sources? Because without this, it's really hard for grid providers to properly incorporate solar plants because they cannot rely on it.
I see.
But
I
we
think
know
I
that-
read, I'm sorry, Melissa,
Sorry.
I think I read at some point of the report that the quality of forecast with 1 week notice, the quality of the forecast increased in 30%. I think I read that.
Mhm.
Hmm.
So it's a huge increase of quality, and then also, of course, a decrease of costs, and of course, I mean, an increase in renewable energy is great for us. So if we can rely more on the renewable energies, this is directly contributing to the Sustainable Development Goal that wants to have affordable and clean energy for everybody.
There you go.
Okay. And we know that we still have like different zone areas in Asia or in Africa who still have like shortage. Do you think that using that technology, how accurate it is to try to solve that problem? And this is the first question. And on another part, like I know that the bank, African Bank of Development, is launching a project to like put solar panel in the Sahara Desert.
Mhm.
How can they use it to finally have a different amount of energy to solve the problem in this area also?
So for the first question, basically you can use this in order to know how much other energy are you going to need in order to have an energy coverage for everybody. If you still don't have enough other energy, this forecast is not going to help you that much because you're just going to know in advance how much you're going to lack energy.
Okay.
But it will help you know, okay, what are my deficiencies? What can I do in order to combat these inefficiencies? And how much do I need to invest into further power plants or into other energy sources?
So for you to get a general idea, Melissa, right now, the common situation is that you have a solar power plant, okay?
Mm-hmm.
And you say, okay, so which is the amount of energy that I will be able to produce 1 week from now? And you give a number, and then climate conditions change a lot, and then such forecast changes maybe 50% or 30%. So what we can do, as I understand, Nathalie, is that we can increase the accuracy of those predictions, of those forecasts.
Exactly.
It's not a matter that you increase the amount of energy that you will gain. It's not that.
No,
it's just that you get more accurate forecast. Because right now, one of the main drawbacks of renewable energies is their unpredictability.
Exactly.
So this increases this helps us in that regard.
But actually, what you can also do is that you use data in order to identify the best spot for your solar power plants, because you know, okay, where did I have historically low cloud coverage? Where did I have historically high solar radiance there? So this you can use in order to find good spots for solar power plants, and also in order to know how am I going to need, like, how do I need to size this plant? How big does it have to be in order to be able to provide enough power?
Okay. Okay, girls. So we have 10 minutes left, so I'm gonna jump right into the last case study, okay? Which is fishery and living marine resource protection. Nathalie, can you tell us a bit how can Earth observation and GPS, how can they help us protect our oceans?
So basically, a big problem that we have at the moment is that too many fish are being fished. A depletion of the oceans of fish, which is not good for the marine life, for the biodiversity, and all of this. But with Earth observational data, you can basically identify vessels in the ocean that are not supposed to be there.
Okay.
So on the one hand, you can use algorithms in order to find out which vessels kind of look suspicious. And then you can investigate this further. And also the ships that are allowed to be there, that have the licenses to be fishing, they're usually in contact with some station and tell them their position.
Okay.
Basically, what you can do is, okay, you have this Earth observational data, and you have the record of where the ships were that are allowed to be there. And then you can identify, okay, which ones really are the ones that are not supposed to be there and which ones have been illegally fishing. And then you can use this in order to combat the illegal fishing that is going on. Because currently I think there's really tons of illegal fish being caught every day.
Okay.
And this way we can help alleviate this a little bit.
Okay. And which sustainable development goals does this application serve?
There's, I think, Sustainable Development Goal 14, which aims to conserve and sustainably use oceans.
Okay.
So directly contributing to that, preserving the wildlife and the biodiversity in the oceans.
Okay. And I assume that such data is provided to mainly governmental entities, right?
Exactly. So this is mainly used by some agencies or governmental entities in order to find these illegal fishers.
Okay.
In order to make sure that they're not continuing to operate like that.
Okay. So for instance, if someone in, I don't know, Marrakesh, or if someone in Togo, if someone in Togo wants to, if Togo's government wants to use this application to detect illegal fishery activities, are they capable of doing it, or is it something restricted to maybe Europe or maybe some other countries? I mean, can any government in the world beneficiate from this?
Any government in the world can benefit from the data that is there.
Okay.
So they can all build their own algorithms, basically. I'm not sure if the algorithm that is currently used is shared all over the world, but as far as I know, it was a governmental initiative.
Okay.
And all the governmental initiatives are usually aimed to help as many people as possible, and then they're usually fine with sharing it with other governments as well.
That's true.
So, yeah.
That's true. Okay.
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 One last question. So the technology allow the government to localize like illegal activities, but does it also provide information about like different species that we have like inside the ocean, like different species of fish or which amount do we have in different areas?
Actually, yes, you can also use the observational data in order to find general patterns in the ocean of, okay, where is a lot of biodiversity? How is it evolving over time? So you can actually track the life that is going on in the ocean and understand how it is changing, and then try to figure out what is impacting it and how this can be, like what can be done in order to reduce the impacts.
Okay.
And how the algorithm can measure how many fishers can be there, like what's the standards? Like it's a bit difficult question, but I'm curious about that.
Basically, if you think about, you have a picture of the ocean, and then you have a lot of dots on there, and those are the ships. And the algorithms can identify these dots as ships, and then through the coupling with the navigation system, you can identify where exactly these ships are.
Okay.
And then you can track these. And there's different patterns basically that are usually done by illegal fishers. So you, on the one hand, can identify these illegal fishers by these patterns. And then on the other hand, you can couple it with the data from like ground stations that are there for the communication of the ships. Because illegal fishers, they don't share their current location, but legal fishers usually share their current location. So you can basically use the data that you got from the pictures, basically, understand where the ship is, and then compare this to the data that you have from these ground stations that know where the ships are that are supposed to be there. And then you see, okay, this one does not have a matching correlation with one of the ground stations, so this is not supposed to be there.
That's very interesting. And another question regarding this topic, Nathalie.
Yes.
Are we capable of gathering data from the deep part of the oceans? Because I assume that we can gather data from the surface of the oceans, from what can be seen with our naked eyes. But in order to detect ecosystems and fish populations, do you know if Earth observation can provide us with data from beyond the surface?
Yes, to some extent.
Okay.
I mean,
to some extent, that's the point.
The sensor
some deep depth,
exactly.
I can think. Okay.
I mean, you don't only have like the normal cameras that that take a picture that you can look at. You also have like infrared cameras and just different types of sensors that are sensitive to different things. And then you can derive a lot of different data from this.
Okay.
So thank you very much, Nathalie, for all those insights. And considering what we have discussed, how do you think that our audience can engage with an improvement, like government, regulators, SMEs, entrepreneurs, the citizens? How can we improve?
I think for me, the most important thing is to kind of read into it and to understand, okay, how can this data benefit our Earth? Because it is freely available. It's this huge chunk of data that is freely available. And I feel like there's a lot of people who are super good at programming and who would be able to really write great algorithms who don't actually know that they can use this data in order to benefit the broader public. So basically read into it, raise awareness, share it with others that this exists. And then if you are good at programming, try and use this data. Try and find applications where you can use this data for the benefit of all and to help other people.
Okay.
Thank you very much, Nathalie. It has been a pleasure having you on board. I could stay for hours asking you questions because it is such an interesting topic that it's so bad that we have no minutes left. But thank you very much for your time. You are an amazing expert in this field, and you definitely are passionate about it, which is also transferred to the audience.
Thank you.
So thank you very much, and see you soon.
Thanks for having me. It was a pleasure.
Thank you, Nathalie.